So we'll start.
Okay.
So welcome everyone. Namaste and Shalom. Thank you for joining us today for this webinar. My name is Karanveer Singh and I am a chemical engineering student here at UPES Dehradun. And today I will be the moderator of this event. So the topic for the event is crossing the valley of death between academic research and climate change policy, the role of behavioral economics. And we are honored to have Professor Shlomo Maital as a presenter. So a few lines of introduction about him. So Professor Maital is an emeritus professor and heads the Zvi Relikas Research Data Center at the Samuel Neiman Institute for Advanced Studies in Science and Technology at Technion, Israel Institute of Technology. Moreover, he has his own course on Coursera by the name of Cracking the Creativity Code, which is offered by Coursera. And as a matter of fact, I was a part of other 30,000 students who were enrolled in this course and completed the 4 courses. So before moving on, I'd like to tell the rules of the webinar. So if you have any questions, you can just type in the chat box and it will be, answered appropriately. Moreover, when you are writing the question, you have to identify yourself. Like, for example, Karanveer Singh, and I'm studying engineering, so I'll write engineering like that, so that the answer is relevant to you. And moreover, we have a Q&A round at the end if there are any questions left. So without much further ado, over to you, Professor Shlomo.
So good afternoon, everybody. Thank you, Karanveer. Welcome. Thank you for joining our webcast. I'd tell you a bit about myself. I'm a retired professor. I've taught at Technion for 40 years and 20 summers at MIT. My specialty is innovation, entrepreneurship, creativity, and startups. Let me say at the outset, I understand from Karanveer that many of you students, most of you in the audience are students, many of you are interested in becoming entrepreneurs. At the end of the broadcast, if you stick out the full hour, I'll give you my email, and I offer free mentoring. I've worked with hundreds of startups, and if you have an idea, want to share it with me, I'll keep it secret. Maybe I can give you some good advice. Thanks for mentioning my Coursera courses, Karanveer. I urge you to think about taking them. I think they're quite practical. It's free. But let me begin by saying how much I love India. My best friend is Indian, Professor Dendaluru Venkatraman Seshadri. That's a mouthful. He's a professor of business at Indian School of Business in Hyderabad. We've written books together, exchanged family visits. He's a dear friend. India is one of the world's largest countries. Israel is one of the world's smallest countries. We're very similar. We achieved independence very close together. Israel in May 1948, around the time India got independence. We both fought the British. Both Indians and Israelis are very good at something that you call jugad. And jugad is frugal innovation, making do with what you have. We do that all the time in Israel because we started off as a poor country and we had no weapons, so we made mortars, we made artillery out of water pipes, and we still do, even though we've become a lot more wealthy. I might just share a story with you about jugad in the Israeli sense. So Israel lives in a really bad neighborhood. Our neighbors don't like us. So sometimes they fire rockets at our cities, and that's very unpleasant. So we needed to find a way to stop their rockets. And we built a missile interceptor called Iron Dome. It's quite amazing because it will intercept a rocket in midair and explode it. And it's 90% effective. And we did it in 2 years. Now, the engineers who were developing it, they lacked a microprocessor, a chip, and they didn't have time to make it. So they found the chip that they needed in the little toy robotic car that one of them had bought for their little boy from Toys R Us. This is jugad, and you do it, and we do it, and it's a powerful tool of innovation. I must confess to you that initially I was hesitant to speak to this group because It's the University of Petroleum and Energy Studies, petroleum. And I'm going to talk about how dangerous fossil fuels are. It's not a super great message for petroleum engineers, but I understand that you get it, that the climate crisis is urgent and that we need to do it. Who better can deal with it than people who really understand the issue of energy? And I will make the case that chemical engineers will save the world. If anybody saves the world, it will be chemical engineers. So thank you for participating. And as Karanveer mentioned, please submit your questions. And I'm going to check the chat from time to time and try to answer some of them. If I don't get all of them, we're recording your chat questions, and I will send you answers, fuller answers later with the help of Karanveer. So first, an apology. I'm an economist. Most of you are chemical engineers. Some of you are managers and lawyers and faculty members. But economists, our job is to destroy the world. We destroy the world. And you chemical engineers, I'll make the argument that you're going to save the world. And I mean that literally. That's not hyperbole. So chemical engineering is the field of engineering that by far has gone through the most powerful revolution in the last 20 or 30 years. Engineers at my university used to go and work in chemical plants and refineries. Some of them still do, but relatively few. Here's what chemical engineers do today. On the screen below, you see a young man. He looks like a teenager. He's actually a full professor of chemical engineering. His name is Avi Schroeder. He's a professor of chemical engineering at my university, Technion. And he's really brilliant. Now, this is what he does as a professor of chemical engineering. He's an expert on RNA, ribonucleic acid. And he uses his knowledge of RNA to create vaccines that help prevent viruses in fish farms in China. He also is an expert in drug delivery. He has a method for using biomarkers that mark cancer drugs. The drug is administered to a cancer patient. It reaches the tumor. Some of the drugs kill cells in the tumor. They do a biopsy then, and using these biomarkers, they can tell whether the cancer drug is effective or not. And if it's effective, they administer it. If not, they give them something else, so they don't waste time on drugs that don't work. This is what chemical engineers are doing today. It's quite amazing. It's literally life-saving. He's also working, of course, on vaccines for the pandemic. Let me tell you about another chemical engineer who's quite amazing. If you ever happen to be in Boston, hopefully one day you'll get to visit Boston or Cambridge, near Boston, and visit the Langer Lab. The Langer Lab is the lab of Bob Langer. Bob Langer is a professor of chemical engineering, but he's known as the Edison of medicine because of his incredible inventions in the area of drug delivery. And on the screen, you can see the startups that have come out of his lab. Now, Bob Langer is a researcher, and he does pure research. But some of those research ideas have applications. And his students who don't feel like being professors go off and do startups, and Bob helps them. So he helps them cross the valley of death between a lab finding, lab research, and a viable business. And there have been a lot of them. If you look at the screen, you can see one of the companies in big letters is called Moderna. Moderna started in Bob Langer's lab. Moderna is one of the two companies that have developed a proven vaccine for the coronavirus, along with Pfizer. And the Moderna's vaccine has proved 94.5% effective. It started in Bob Langer's lab, and it's a mRNA, a messenger RNA vaccine, a new type of vaccine, which is proving effective and will one day perhaps save the world. So I salute you chemical engineers. It's an incredible field. It's changed immensely, and it's going to save the world. So let's talk about climate change. The first assessment of climate change related to India, the Indian region, was published just this June, right in the midst of the pandemic. The Ministry of Earth Sciences of India, the national government of India, published an assessment of climate change. I think that's an excellent thing that they've done, despite the pandemic. They present several scenarios. In the worst case scenario, this is what they found. The average surface air temperature over India could rise by up to 4.4 degrees centigrade. That's 8 degrees, nearly 8 degrees Fahrenheit by the end of the century, as compared to the period between 1976 and 2005. 8 degrees Fahrenheit rise in temperature. That means that the Earth will be almost unbearable. Now, I'm an old guy, and my wife and I have been blessed with many grandchildren. We have 16 grandchildren. Some of you may be married, some of you may have children. Our children and our grandchildren will live during most of this century. And this is what we are bequeathing them, a planet that is almost unlivable. This is unacceptable, unacceptable. And it's important that we have brilliant people like yourselves who are concerned about the problem and are able, have the knowledge and technology to tackle it. Now, how long have we known about this problem, that the carbon dioxide is causing global warming leading to climate change, which we now call a climate crisis, because it is a crisis. So this graph shows the average global temperature. And you can see that it was declining from 1880 to about 1900 or 1908. And from 1908, consistently, the global average temperature has risen. Now, what happened in 1908? How come the curve turned around and started to rise in 1908? Well, here's the answer. The first Model T Ford, built by Henry Ford on the first assembly line, he invented mass production. The first Model T Ford was produced in August of 1908. And over the years, 15 million Model T Fords were produced until they went out of production. And of course, the auto industry grew and expanded. And today we have 80 million cars and trucks in the world, 80 million. So we've known for a long time that we're spewing carbon dioxide into the air. And the question is, what have we done about it? And how is carbon dioxide related to the rise in global temperatures? So looking at the graph on your screen, on the left-hand side, you have the rise in temperature from the turning point around 1908, the average rise in temperature. And on the right-hand side, you have parts per million of carbon dioxide in the atmosphere up to 2019. And those two graphs track almost perfectly. So the rise in temperature from 1880 to 2019, from minus 0.03 to about 1.1, temperatures have risen on average by about 1.5 degrees. We're seeing unprecedented hurricanes during this season. So many hurricanes, by the way, in North America, that we run out of names, and they now use Greek letters. Hurricane Eta, Hurricane Iota, Hurricane Zeta, and they're devastating Central America. And you too in Asia have seen typhoons, and they've been terrible. And this is only because of about 1.4 degrees of global warming. I showed you the study of the Ministry of Earth Sciences in India, which projects a 4-degree centigrade rise in temperature. Imagine what havoc that will cause. So looking at this graph, when do you think people should have begun to be concerned about global warming caused by fossil fuels, and carbon dioxide. When should we have woken up to this? Man, we have a problem. 1908, 1920, 1930, 1940, 1970. When do we wake up? Why didn't we wake up? Why have we been asleep? Why is there a valley of death between what scientists show us, like this simple graph, and everybody can see it in front of their eyes, and the failure of public policy, failure of governments to do anything, and the most incredible insanity or evil, the Trump administration leaving the Paris Agreement and denying that there is such a thing as global warming, denying the science. It's unbelievable. The world's wealthiest, most powerful country opting out of dealing with this global problem. So I want to ask 3 questions and discuss them with you. The first question is, when did credible research first recognize the warming impact of carbon? When did we first figure out that carbon dioxide is like a big blanket, blanketing the earth and warming it up? And when did we start to take impactful policies to limit carbon emissions? And which of those policies has been most effective? So my answer to the first question, I think I found it quite amazing when I did some research. We have known for 164 years that carbon dioxide causes global warming. Even before the automobile was first produced by Henry Ford, 164 years we've known it. Chemical engineers have known it. How did we know it? A brilliant woman scientist, and there weren't very many in 1856, she did a simple experiment. And by the way, there's a lesson here for you chemical engineers. You can do very simple experiments with very limited resources. You can use Jugad in your labs to create brilliant ideas. You don't need billions and billions of dollars. And this is what Eunice Foote did, a scientist named Eunice Foote. She took a glass jar and she filled it with water vapor, and then another glass jar and filled it with carbon dioxide. And then she took another glass jar and filled it with air. And then she simply measured the temperature. How much did they heat up in the sun? And she found the highest effect of the sun's rays I have found to be in carbonic acid gas. Carbonic acid gas is what they called CO2, carbon dioxide, in those days. And this has been published. It was published in an 1899 book by another scientist who said that changes in climate could result from changes in the concentration of atmospheric carbon dioxide. So we have known about the role of carbon dioxide emissions in global warming for 100 years, more than 100 years, and yet we've done nothing, relatively nothing. Have we done anything? Are there any policies that have really had an impact? So we had the Kyoto Protocol that was extending a United Nations framework, and it was adopted in Kyoto, Japan in 1997, the end of 1997, December 11th, 1997, 23 years ago. That Kyoto Agreement expired in 2012. It was partly replaced later by the Paris Agreement. But the truth is, not much of the Kyoto Agreement was actually implemented. The most effective action to date that limits emissions partly comes from brilliant chemical engineers and electrical engineers and entrepreneurs, and that is renewable energy. If you come to Israel, when you come to Israel, I hope Karanveer will come and visit us in Israel, and I welcome all of you students. When travel becomes easier, I welcome all of you to come and visit us, and I'll take you to meet some entrepreneurs and to see our country. In Israel, when you come to Israel, if you look at the rooftops, including the rooftop of our house, you will see solar panels. So by law, every Israel building Every Israeli building has to have a solar water heater. And all of our hot water comes from solar energy. We also have big solar farms that create electricity as well, but we've had these solar water heaters for decades, partly because we're a poor country and it saves money. So solar energy, the cost of solar energy is now far lower than many other forms of energy. This is partly true of wind energy as well. So in the end, economics trumps policy. If it's cheaper to make energy through solar power, people are going to use it. And this is talented entrepreneurs and engineers who have found ways to make solar panels that used to be really costly. By the way, the Chinese are leading the world in this. They produce solar panels. They do it cheaply and efficiently with tremendous scale. And that's proved highly effective. Now, the question that troubles me a lot as somebody who's spent his career inside a university, why are there these two terrible, destructive valleys of death? There is a place in the world, by the way, called Death Valley. It's in the southwest United States, and it's the hottest place on Earth. The temperatures go to 120, 140 Fahrenheit and more. There is a valley of death in the world, a metaphoric valley of death between scientific research and public policy. So I've shown you graphs showing scientists have known for years about global warming, for decades, for more than a century. We've known that, but politicians have failed to implement policies to do anything about it. A valley of death between what scientists recommend and what governments do. And the question is why? And what can we do about it? There's another valley of death, and I talk about it as a professor of innovation. I won't talk about it today, but privately we can discuss it. It's a valley of death between technology developed in laboratories and successful businesses. So many of you, I understand from Karanveer, and I'm very, very pleased by this, many of you students who joined this podcast, including Karanveer, intend to become entrepreneurs. And you will take technology that you learned at your great university, and you will create value out of it and hopefully create viable businesses. But in doing so, you will be crossing this desert where there's so many things that can go wrong. You run out of money, you hire the wrong people, you take a wrong turn, a wrong decision. Your product has flaws and so on. So that's also a valley of death, but I want to talk about the first one. Why is there a gap between what scientists say and what politicians do and what people believe? Because there's been a decline in the degree to which people trust the science. This graph on your screen shows the percentage of people who trust government in Washington. This is in America. These are data that I know best about the United States. And the United States has been the place with the worst decline in trust in government, partly because of a broken political system where the Trump administration has talked about the deep government, the deep dark government, the deep state, the fake news and the fake scientists, and cast doubt on climate change, rejected climate change. And this decline in trust in government has been part of the difficulty in implementing effective climate change policies. The other problem, perhaps a bigger one, was expressed by Jean-Claude Juncker, Prime Minister of Luxembourg and later head of the European Commission. And he said it really simply. We political leaders, we all know what to do. We just don't know how to get reelected after we've done it. What does he mean by that? He means that in order to combat climate change, we may have to cut back on our standard of living. We may have to stop plundering our planet just to enjoy short-term economic gains. And we have to find ways of sharing that burden among different countries. It may be that we've been living beyond our means and stretching our planet's resources. We have to stop it because it can't go on. But how do you get people to recognize that we've lived beyond our means? We've had a big party. We got to stop partying and start to act responsibly. So I think there are two ways to do this. One way is to try to change government policy. We have a new president elect in the United States, and he gets it, Joe Biden, and he has a strong green policy, and he will bring America back into the Paris Agreement, and that will be a positive change. But it's just a very, very small start. So I want to propose a second approach to all of you, especially to you students. And that is, we have to change our behavior bottom up. You change policy by changing the way people behave. And you change the way people behave by, first of all, getting them to understand and believe the science of global warming and the climate crisis. And then finding innovative ways to deal with that crisis as entrepreneurs and as citizens. And as your individual behavior, using less plastic, trying to use electric vehicles. India has an incredible 250 million vehicles, most of them scooters and motorcycles and smaller engine vehicles, and a large polluting problem. How can you clean this up? How in India can you clean your air up? By creating vehicles that are cheap, but also environmentally friendly. If things are going to be saved and if the world is going to be changed, it's going to take creativity, the creativity of engineers in devising creative solutions. If we wait for our leaders, for our politicians, I'm afraid things are going to get a lot worse. I want to talk to you, changing the subject. I want to talk to you now about creativity, innovation, entrepreneurship, ideas. And I want to tell you how to win a Nobel Prize. I want to tell you this because understanding that many of you do want to become entrepreneurs, there's a lot of similarity between starting a successful startup and winning a Nobel Prize. And I'll explain. On the slide, you see a small picture of my close friend, my colleague at the Technion, Professor Dan Shechtman. Dan won the Nobel Prize for Chemistry in 2011. His discovery was something called quasi-crystalline material. Now, you chemical engineers understand that crystals are matter that is highly organized, highly regular, systematic, and organized. Dan, using an electron microscope, took a photograph of an aluminum alloy, and he discovered a crystal pattern that was not perfectly regular, quasi-crystalline. And when he sent the electron microscope photographs to experts, all experts in material science, wrote back and said, Dan, you messed up your photograph. Do it again. This cannot be. This does not exist. This is against the prevailing theory. And Dan said, I'm an expert on electron microscopy. This is a real finding, and I'm going to figure out why and how this works. He presented his results at a conference. The world's greatest crystallographer, the world's greatest chemist, Linus Pauling, some of you have heard of him, Nobel Prize winner, 2 Nobel Prizes. He won the Nobel Prize for Peace as well. At a conference, Linus Pauling said, ladies and gentlemen, we have here at this conference a quasi-scientist who thinks that he has discovered quasi-crystals. but they don't exist. Don was humiliated, stuck to his guns, published his results, did the theory, and won a Nobel Prize in 2011, proving that he was correct. What has this got to do with being an entrepreneur? First of all, you have to ask challenging questions. Tackle really, really tough problems. If you're going to spend years of your life working on an idea and struggling and working 24/7, you might as well tackle something meaningful. So ask big questions, take on big challenges. When you do so, challenge all assumptions. Ask hard questions of your professors. Some of your professors will love it. Some of them will be really annoyed when you ask hard questions. Pay no attention. Ask really tough questions and challenge your professors and challenge all the assumptions. Because some of those assumptions that we know to be true, like crystals are always perfectly regular, well, some of those assumptions are wrong. And you can prove them wrong. So question all assumptions. And then when you come up with a great idea and you try it on people, they will tell you, you can't do it, you won't do it, it's not possible, it's crazy, nobody will buy it. You'll have the naysayers. And you have to be stubborn, very stubborn, and persist in the face of all those naysayers. And hopefully in the end you will prevail. So I've been blabbing on a lot. I'm going to try to find your questions in chat. Question, who could be the leader in climate reform if the USA has opted out from the Paris Agreement? The leader in climate reform, if the US has opted out, can be India. India is an entrepreneurial country. You have a large population. You have, in some cities, awful air pollution. I've been in Bangladesh. I've been in Bangalore. I've been in Bangalore when it was almost impossible to breathe. So you have a large population, a difficult problem with pollution, difficulty with global warming. Continued global warming will lead to a rise in the sea level of up to 1 meter in the coming decades. That's disastrous for many Indian cities, including Mumbai. So you have a big problem, and you also have the ability to take leadership and to find ways to deal with it. The problem is that we in the West have plundered the planet and become wealthy. And now we're saying to the poorer countries, okay, so now you guys have to sacrifice. And this is very unfair. This is a difficult problem. India can take the lead, but unless the wealthy countries make a large sacrifice as well, then it will be totally inequitable. And we can't tell Asia to stop producing just because the West has lived beyond its means for many decades. So this is a global problem. But I think you've noticed recently 14 Asian countries signed a free trade agreement. This is creating like a European common market in Asia, and it's really important. So Asia has the ability to collaborate and cooperate, and we're seeing this now. Despite some rivalry between China and India, you have a common interest. So I think Asia as a group of countries can work together and collaborate, even without the United States, which is mired in its own lack of democratic swamp. Other questions? Karanveer, please, do you have a question?
No, so right now I don't have any.
Okay. Let me try one more time. Please, students, this is your chance. What are your questions? What are you curious about? What about questions about my country, Israel? We were a very poor country in 1948. We now have GDP per capita of over $40,000. We're called the startup nation. What would you like to know about my country? Karanveer, if you want, you can unmute people and they can ask me the question directly.
Okay, sir.
Yes, EU is, all right, one more question. EU is already set for 2050, net zero carbon emissions. How far is India to reach it? First of all, that goal for the European Union, that's 30 years from now. That's a long time. And a lot of people are doubtful that they're going to make it. India is even farther away from that. So I think India needs to find a way, as chemical engineers, can you find a way of inexpensively converting internal combustion engines to vehicles driven by electric power? And that alone isn't enough, because if you make electricity with coal, you haven't gained anything. And can you find ways of generating alternate energy, electricity, with wind and solar and other approaches, so that you can power vehicles with electricity and make the electricity cleanly and cheaply? I noticed that the UK has banned petrol and diesel. That's true. Thank you for that question. By 2030, that's only 10 years away. We'll see how that works out. But changing standards can really be helpful. When the United States and California changed the emission standards for vehicles, California was a leader in that. California did it because California's pollution problems sometimes are as bad as India's. When California did that, the auto industry as a whole completely changed their production methods and found ways of increasing gasoline mileage. So set the bar high, change the standards. The auto industry will fight like hell. But if you do that, they will find a way. They will employ chemical engineers, bright ones from your university, to find a solution. How do you expect people to deal with climate change when they can't even wear a mask during this pandemic? Absolutely. So I live in Israel and people here are wearing masks, but I have family in America and spend time in America. And Americans are nutty, because half of Americans think that wearing a mask means that you're politically identified with the Democrats rather than the Republicans. It's mind-boggling, absolutely mind-boggling. And they're led by the former president of the United States, who was a total idiot. So you're absolutely right. We need some real leadership. Europe, by the way, is having a second wave. They're coming out of it. They're helping people who've lost their livelihood. People in Europe wear masks, and they will come out of it before the United States. In Asia, people wear masks all the time, and they think nothing of it, even before the pandemic. And in America, it's a political issue of individual liberty. People have the right to spread the virus and kill other people because it's individual freedom. It's mind-boggling. And it's a matter of leadership. I hope the new president will change that. But the last 4 years have been horrendous. Given that renewable sources provide only a small percentage of our energy, and nuclear power is so expensive, what can we realistically do to get off fossil fuels as soon as possible? I have a car. It's a hybrid. It runs cheaply. It still uses gasoline and it still pollutes. The next car will be all electric. That won't be a whole solution because Israel still produces electricity somewhat in a dirty fashion. We use natural gas. Natural gas is cleaner, but it's not perfect. We need to get vehicles to become electric. That's number one. Number two, we need to produce the electricity in far more clean manner. Those two things together. We need to get electric vehicles, we need to get the price way down. We need Tata to produce a really cheap electric motorcycle and a really inexpensive, convenient, comfortable electric car. Israel became startup nation. What is the main reason behind the great transition to becoming startup nation? So before the pandemic, I had the privilege at my university of hosting people from abroad, and we had endless parades of blessed visitors, many from China, by the way. We had so many people come from China, and they all had the same question. What's your secret sauce? What is your secret sauce? And I had a standard answer. I have no idea. I don't know. And I've lived here for 53 years. But I have some theories. Let me tell you one theory. So there was a Jewish person, a Jewish physicist named Isidore Rabi, and he did work on something called nuclear magnetic resonance, NMR. Nuclear magnetic resonance is the basis of MRI, magnetic resonance imaging. And MRI today saves millions of lives because it helps doctors diagnose difficult problems and find tumors. Why did Rabi win the Nobel Prize? So he was asked that question. He was a professor in America. Rabi's mother and father were Jewish immigrants from Russia. And they emigrated to America and worked very hard and were quite poor. When Isidore used to come home from school and his mother would greet him, many of our mothers, when we come home from school, would ask us, so Shlomo, what did you learn in school today? Isidore Rabi's mother didn't ask him that question. She asked Isidore, what good questions did you ask in school today? He was trained to ask questions. So we Jewish people, we have a holy book, apart from the Bible, called the Talmud. The Talmud is a 2,000-page complicated book with arguments by the rabbis. And it's totally a book of fierce arguments about religious practice. Jewish people, if you've known Jewish people, we like to argue and we all have opinions. And even if the prime minister is in front of you, you still tell the prime minister what you think. We're stubborn people with our own opinions, and we ask hard questions. And we don't like people telling us what to do. In history, we haven't been allowed to do many things, to own businesses or land, run big businesses. We've had to make a living as kind of entrepreneurs. So it's sort of in our blood. By the way, it makes Israel a really hard country to govern. We are stubborn, implacable people. But part of that is that we have young people who have really good paying jobs as engineers. They graduate from Technion, they go to work for a company. They're making really good salaries with great benefits and a promised pension. And they quit because they have an idea and they're tired of people telling them what to do. So they go off and start businesses and they fail because most startups fail. And after they fail, they try again because we understand in Israel that startups fail and that failure, there is no such thing as failure. There's only another step toward being successful. Question, video of South Korea They have a cyclist lane covered by a solar panel. That's really interesting. Do you think countries should come together and share such ideas? Absolutely. So we've had disastrous 4 years of America where the president says his goal is to make America great and screw the world. We should have a global vaccine program where countries cooperate on creating a vaccine and producing it, and then sharing it among countries globally. And there is such a program. It's run by the World Health Society Administration, WHO. But America isn't part of it because America under Trump was only for America. So yes, we need to have a global conference, and the global conference will talk about ways of dealing with the climate crisis, but I mean effective ways and cooperating as well, absolutely. And we may have that because the new US president has talked about actually doing something similar. And by the way, waste, do you know how much food we waste? Israel wastes between a third and a half of all the food that we grow and raise. A half. That's unbelievable. So there are many things we can do, you and I as individuals. We start by reducing the amount of food, edible food that we throw away. Absolutely. Can electrochemical technology be the idea for pollution control? I told you I'm an economist. I wish I could answer that question. I don't think so. I think we're going to need really new, different, radical technologies. We have an Israeli physicist at my university who's sort of working on the area of lasers. He comes from Princeton originally. Princeton and other universities in the US are working on generating electricity from nuclear fusion, like hydrogen bomb energy, only captured to create electricity. And it's really difficult because the temperatures are millions of degrees. How do you hold that in a vessel? But it may be that powerful lasers can ignite hydrogen atoms to fuse and generate energy from nuclear fusion. We're going to need some really radical new technologies rather than electrochemical, I think. But I'm just an economist, and what do I know? Solar panels have limited lifetimes. That's true. Most of the panels in the world will lose efficiency. That's true. But we've reduced the cost of solar panels. We've improved the technology. If we invest enough in solar energy, we'll find solutions. That's a great problem for a chemical engineer to tackle. You tackle it. You tackle it. How can you make better solar panels and more efficient ones? Absolutely. BEVs for the future. What about cost competitiveness between FCEVs and BEVs? Karanveer, help me out here. What are we talking about here? What is that?
I request everyone when they're sending the questions, send to everyone so that everyone can view.
Okay, so I'll read the question. Calling out BEVs for the future, then what about the cost competitiveness between FCEVs and BEVs? Interpret the question for me.
I also don't know that.
So unmute whoever it is from Sanskar Vaishnav.
I'll unmute.
What are, please unmute yourself and
Okay, so my question was like, we are talking about BEVs for the future. So, what about the cost competitiveness for the future? Talking about the FCVs, that is fuel cell electric vehicles, and battery electric vehicles, because reading the Hydrogen Council report delivered latestly in 2020, they are saying that FCVs will cross BEVs market by 2040 maybe. So how effective that solution would be?
so again, I have no idea. I wish I did. And frankly, I wish I'd studied something useful rather than economics. But I promise you, I will look into that question and ask people who know, and I will get back to you by email. So thanks for the question. So we're getting close to the end. We have 5 more minutes. Any more questions that you want to send by chat? Here is one. What took experts so long to notice climate change? Even scientists found carbon dioxide is bad for the climate years ago. Why did that take so long? So I think one reason is that scientists work hard in their labs, and very often they don't take time to communicate in simple language with ordinary people. And even when they do take time to write for the newspaper, they don't really know how to write clearly and simply and explain things without jargon. So here is a mission for you chemical engineers or students of chemical engineering. Make it a practice when you learn about amazing new technologies. Make it a practice to find ways to explain it to your mom and dad in simple language that they really understand. Because if we are going to tackle this problem, we have to explain things to people. We have to explain to them, why is it that fossil fuels create carbon dioxide, and why is that causing global warming? And why does global warming cause the level of the seas to rise? And why is it changing our coral reefs? We have to find ways to explain that in simple terms. My profession, economics, is the worst in the world at doing that. We baffle people with our math and with our jargon. So we need to win the trust of the people back, and we need to do that by explaining and speaking in language that everybody can understand. And it's not easy. It's not easy to explain ribonucleic acid to ordinary people and how it works, but it can be done. If you guys are going to be entrepreneurs, you're going to stand in front of investors and you're going to pitch your idea. And you can pitch your idea in the language that you learned in university, and they won't understand a word because many of them have money but not much technology background. Or you can explain it to them so beautifully and so clearly with little examples. Like the beautiful experiment that I mentioned to you, the scientist, the lady scientist, who took little jars and tested global warming to see if carbon dioxide is a better insulator than ordinary air. Find ways of explaining your concept beautifully and simply so you can excite people. Great entrepreneurs excite ordinary people with their idea and gain money and support. And we need to do that in the climate crisis as well, in ways that people understand it, that impact their own lives. Here is how global warming is going to affect you in the next 10 years. And the second part of that, here is what you need to do as a person, as an individual, in your own little way to help solve the problem. Can you waste less food? Can you use an electric vehicle and you take public transportation? Turn the lights off? This awareness, our children have that, by the way, I think. And it's the older generation who are used to our wasteful practices. So the kids offer us lots of hope. So Karanveer, I promised you I would quit exactly in 1 hour, and the hour is up.
Yes.
I've really enjoyed speaking to you and meeting you.
Yes.
I'm going to put this slide up, and it has my email. I renew my offer. Those of you who have entrepreneurial ideas, If you feel like sharing them with me, I'm happy to try to mentor you. I have quite a lot of experience in working with startups. I am working with startups. So please send me emails, and I look forward to having new friends from your university in India. Karanveer, thanks for initiating this, and to all of you participants. Let's see how many we have. We have 67. That's a goodly number. So
Yes.
to all of you, thank you very much.
Yes, sir. So it seems that we've covered all our questions, and the questions that are left, I'll send you through email so that you can answer later on. So, is
Excellent.
there anything you want to say before a wrap up?
Yes. So those of you who are students, and many of you are students, become T-shaped. This is advice from a Nobel Prize winner. So find something in chemical engineering that you become really, really, really expert at, and go very deep into that particular technology. While you're doing that, open your mind and learn about all kinds of other things, way beyond chemical engineering: physics, economics, business, politics, sociology. Develop broad curiosity in a wide range of things. So become T-shaped, some area that you are really expert in, and then a lot of things where you know a little bit about it. That combination will make you a strong entrepreneur.
Okay, sir. So now I'd like to invite our Joint Secretary, Sakshi. She will deliver the vote of thanks. Sakshi,
Thank
over
you
to
so
you.
much, Karanveer. It's my great privilege to have been asked to propose the vote of thanks. So, on behalf of the IACHE UPES student chapter and Karanveer, all our volunteers and the chemical department, I would like to extend a very hearty vote of thanks to you, Professor Shlomo Maital, sir. Thank you so much for coming here and inspiring us and asking us to, ask more questions, be more inquisitive about our own subjects, and, help us grow. So thanks to you, sir. And I'd like to thank our faculty members for supporting us, all the audience we have, the student chapters, and every student we have amongst us. Thank you for joining us. And thank you so much. That's it.
Thank you, Sakshi. And someday I look forward to visiting your beautiful city and meeting you all in person.
Thank
Thank
you,
you,
sir.
sir.
Bye-bye.
Bye.